Histamine also acts as a chemical messenger between cells in other areas of the body, like neurons in the periphery, skin, lungs, and capillaries. What does histamine do? A common histamine response, let's just something everyone knows, poison oak, poison ivy. When you touch it, right, your skin gets red, it itches, and it's painful. That's a histamine reaction. The allergen or the proteins in the poison oak are viewed as a threat to the body or an insult or an attack, and it reacts by releasing histamine. What causes histamine response? Pet dander, allergens, foods, drugs, chemicals, venom. It seems like this could be very dangerous, histamine. Why does the body do it? Well, histamine, for most part, saves us. Tissue injury, when you have a trauma and an area of the body is damaged, histamine is released in that area. It's released by mast cells. These mast cells have these little granules, and when an injury occurs, the mast cells in that area release histamine. They open up the capillaries, and white blood cells and other protective blood products enter that area and treat it and help the injury. Basophils, which are white blood cells, also release histamine. It makes sense. White blood cells fight infection, so it makes sense that a white blood cell could release histamine, open up capillaries so they leak, so more white blood cells could enter that area to protect it. Let's say the body's attacked by a bacteria. Let's say the body is attacked by some sort of amoeba or parasite, or there's a cut with infection on it. Well, that area will inflame. It will fill with fluid. It'll turn red because histamine is released, and that's the body's protecting itself. But that's the good. So a bacteria, any other insult or a tissue injury, parasite, it protects us. Great, that sounds great. But what happens when it goes wrong? Okay, so now we have a problem with histamine when it goes wrong. For example, when you get a drug. How about when you get a chemical? How about when you get exposed to a food like a peanut or pet dander or ragweed or pollen or some allergen in the air? Well, now you're getting a histamine response when there's nothing really to repair and there is no injury and there's no bacteria and this can't really hurt you. And so what happens? Well, it's something called anaphylaxis or a histamine response. And what that is what happens when you get ragweed or an allergic rhinitis, we call it. 5% of America suffers from these histamine type reactions or allergic rhinitis, and 5% of all kids have some food allergy, like to peanuts. But drugs, you can get anaphylaxis. And what does the body do? Well, histamine, when it's released, drops your blood pressure by sort of the capillaries open up. That makes sense when you want to protect an area and make them leaky. When you open them up, the blood slows down and allows for white blood cells and healing products of the blood to enter that area. But if you're just exposed to an allergen, pet dander, a food, a chemical, a drug, well, that's not good. So you drop your blood pressure down. That's one thing that histamine does. But another thing it does, it speeds up your heart. And it speeds up the contractility, the pumping, and the rate of pumping. It also constricts the lung. It also hits the neurons in the skin, causing them to itch and be in pain. You know, one thing I know from dealing with people who've used opiates, opiates release histamine, and that's why when you use an opiate, you get itchy because it causes a histamine release, itchy and painful. It also affects the neurons in the skin, causing pain and discomfort, and bumps form on the skin. I'm talking about all these qualities of histamine. This can lead, I've been in the emergency room, I worked for 20 years. And I'll tell you what happens when someone's having a drug reaction, or I've sent patients who are having some sort of anaphylaxis. Anaphylaxis is modulated in the body by histamine. It's usually, there's 4 histamine receptors, H1, 2, 3, and 4. The anaphylaxis reaction is modulated by histamine receptors, H1 receptors in the lung, the heart, the skin, and peripheral neurons. It's also modulated by H4 receptors and basophils. All right, so now you have a problem with someone whose blood pressure drops to really dangerous levels, can't perfuse their organs, they're tachycardic, their heart rate speeds up, their blood pressure drops, their heart rate speeds up, they are getting, they get like confused, their skin turns red, they get bumps all over it, someone could die. Anaphylaxis, this is where histamine is trouble. I mean, it's really trouble. It scares the living hell out of me. And what you do is, to stop this cascading series of events, epinephrine. Epinephrine opens the lung up so you could breathe. Epinephrine closes the capillaries. And we also give steroids to sort of modulate the body's immune response and help it deal with stress. So and we pound them full of fluids, IV fluids, because their blood pressure's down and the heart's going skyrocketing. That's some basic treatment. So epinephrine is the treatment for anaphylaxis. Now let's get into this a little bit more. There's more to this story. There's 4 types of histamine receptors, H1, H2, H3, and H4. This is complicated. H1 and H4. H1 is in the skin, the lung, the heart, and some peripheral neurons. H4 is in white blood cells called basophils. Okay. That modulates anaphylaxis. That means a histamine response to a chemical, a drug, an allergen. And we know when we put drugs in people, we put chemicals in them or venom, that could kill them. Anaphylaxis is deadly. Okay. H1 is the receptor that works in the periphery, but it's also present in the hypothalamus, hippocampus, cerebellum. Where's the hypothalamus? It's a major area of the brain, sort of a control center for neurons. Go like this. Go up in your nose. You'll hit your pituitary. Above your pituitary is a hypothalamus. It's a little area, sort of a grand central station where all neurons come together. It sits right above the pituitary, and it controls some of the functions of the pituitary. So there are H1 receptors there. So there are central nervous system effects to histamine in the hypothalamus. And the hypothalamus also controls the pituitary. It controls the adrenal gland by its control of the pituitary, and that controls cortisol and adrenaline are secreted from our pituitary, and that's directly under control of the hypothalamus, which is affected by histamine. So those H1 receptors are also there. There's unique qualities to the H1 receptors in the hypothalamus, and this is why it's my favorite drug, because those H1 receptors in the hypothalamus, which are stimulated by histamine, control alert, keep you alert, help you learn, help you feel good, help you do projects, help you initiate things. They control addiction, and they help you lose weight. Yeah, I like that. That's why, and also through that area of the brain's control of the pituitary, which controls the adrenal gland, which controls cortisol, which is a natural steroid in the body that helps control stress. It's another lecture, but it also controls the thyroid, which controls metabolism and a host of other issues in terms of skin and hair and nails and heart rate. It controls a lot, the thyroid. Think about that. You're controlling the adrenal gland, the thyroid. You control melanocytes, which control how you tan and how sun affects the body. What else does it control? It controls prolactin, which is helps us socialize with people and controls milk production in women. So all these H1 receptors control the hypothalamus, which is huge. Think about what it does. Sleep, life cycle, learning, memory, initiating projects, weight loss, and addiction. That's huge. But H1 in the periphery, H1 receptors are what all common antihistamines are based on. Antihistamines, the periphery of all these throughout your body. Remember, the lungs, the skin, the heart, peripheral nerves have H1 receptors. Now, so when we want to stop an allergic reaction, we can give drugs. For example, a common one that blocks this H1 receptor, diphenhydramine, Benadryl. Everyone knows it as an over-the-counter antihistamine. For an allergic reaction, put Benadryl cream on a poison ivy, or you can take it when you're having hay fever, allergen, pet dander, or having an allergic reaction. The doctor will tell you you're having an allergic reaction to a drug. Take Benadryl, 25 to 50 milligrams. Okay, so that's an antihistamine. But why does it have all these other side effects? Because not only does it block the peripheral antihistamine, which blocks the release of histamine from mast cells, which release these granules and release histamine into the body, which cause everything I talked about, it also crosses into the blood-brain barrier. These are very small molecules. There's something called lipophilic, which is not good. That means it gets into your brain, goes to those H1 receptors. Remember, we don't want to be blocking, lose weight, think clearly, be alert. We don't want to block all that, and that's what it does. Because as good as diphenhydramine Benadryl is, it deals the periphery and deals with those H1 receptors, those histamine receptors in the periphery, but it goes into our central nervous system and does all those things I love about histamine. It blocks them. What else? It's a dirty drug. And when psychiatrists, psychopharmacologists, when they say something's a dirty drug, you know what they mean? They say it hits other receptors. So not only is it not just dealing in the periphery, it's going into my brain and shutting down some really good brain functions, but it's not just hitting histamine. Wah. It hits acetylcholine. Acetylcholine, it hits a specific type. God, I hope I'm not losing people. This is for my friends in Toronto. You asked for me histamine, and now I'm doing it, but it gets complicated. So now you're hitting the anticholinergic, the acetylcholine receptors, you're blocking them. Acetylcholine, it's called the muscarinic, centrally located acetylcholine receptors. You need acetylcholine to think clearly. It keeps you awake. Acetylcholine is the neurotransmitter which keeps the autonomic nervous system, all the stuff you want to do you don't think about, like keep your gut working, so you block it, you get constipation. It's doing that. You want to keep your eyes working so they open and close according to light. It blocks that. They get stuck in the open spot because you're blocking the acetylcholine, which regulates the eye opening and closing, the pupil. In Renaissance Italy, women used a plant, Atropine belladonna, which blocks acetylcholine in the eye. They would put extract of the Atropine belladonna plant in their eye so it would be stuck. The pupil would open and they would have these big open eyes and think it was so beautiful. Belladonna, Atropine belladonna, that means cute woman. You get it? So that's what they're doing. They were blocking the acetylcholine muscarinic receptor in their eye. What else does blocking this receptor. Oh, you know what else? I've never done this, but there's something called scopolamine, and scopolamine blocks centrally acting acetylcholine receptors. And if you do an IV drip of that, you could get people to a state of almost delirium where every time you ask them a question, they'll tell you an answer, no matter what it is. I've never done that. So anyway, that's just a scopolamine little tidbit of information in the atropine. But we're talking about the acetylcholine receptor, so it causes blurred vision, constipation. It blocks your mouth's ability to produce saliva, so you get dry mouth. It blocks your bladder, so you can't go to the bathroom. You get urinary retention. You get a lot of nasty side effects. So diphenhydramine, which was Benadryl, yes, it blocks those centrally acting histamine receptors, but it's a dirty drug. It also blocks acetylcholine receptors in the central nervous system. Wah! It does something else. It's alpha adrenergic. It blocks the body's ability to regulate blood pressure. And so it can cause dizziness, reflex tachycardia, because it drops your blood pressure down because your body can't modulate and bring its blood pressure up. So you stand, boom, your blood pressure doesn't rise like it needs to, and your heart goes crazy. It also blocks serotonin, which could make you eat more. See what's going on? So you say diphenhydramine. It's a great antihistamine, but it also blocks acetylcholine, cholinergic receptors, alpha adrenergic receptors, blood pressure, and serotonin. So that's why diphenhydramine also works as a sleep aid. There's other drugs here. I'm going to go through a list a little bit because these are antihistamines. Chlorpheniramine, chlortrimetron, remember that one? That's why they have all these nasty receptors. Yes, it'll block the histamine release, the allergic response of the body to allergens and pet dander and ragweed, but it also is a nasty drug blocking anticholinergic, so dry mouth, blurred vision, constipation, urinary retention, drowsiness. Yeah, that's why these drugs aren't great. Propheniramine, Bromax, that's called, another antihistamine. Clamastine is another one. Tavist, remember that? I'm just getting these names so people are familiar. Oh, that's all what these drugs do. There's a million of them. And every time I look, there's a new one, and they all end in E. They do other stuff too. Hydroxyzine, that's an antihistamine which has also centrally active anticholinergic effects, and we use it to decrease anxiety. It can also block rash. Remember I said that the antihistamine stimulates the nerves to release histamine, causing itching and rash? Well, other drug names this drug is Atarax, Vistaril. It also slows down the nerves in the central nervous system of the acetylcholine, which relaxes people. There's a drug that is another antihistamine called meclizine, Antivert, which stops dizziness by it has that antihistamine effect, but it also has an centrally acting vestibular in your ear. It slows those nerves or quiets them down so you don't get dizzy, vertigo. Antivert is the brand name for meclizine. I use it for people who get dizzy because it has an antihistamine response, but it also has a centrally acting vestibular anticholinergic response, slowing down the firing of nerves in your ear, which stabilizes people and prevents dizziness. When it gets out of whack, you want to slow it down and calm it down. Antivert, meclizine, it's an antihistamine that also works as an anticholinergic agent in your ear. There's other ones. Diphenhydramine, Dramamine, stops nausea. These drugs also stop nausea by hitting in the chemical center or the nausea center of your brain. Hitting anticholinergic centers. They're antihistamines that can also be used to treat nausea. It's called Dramamine, but it's an antihistamine with anticholinergic properties. What are some other ones? Benadryl, chlorpheniramine, chlortrimetron, Tavis, clamastine, hydroxyzine. What are some other juicy ones? Dizziness. I'm trying to think of some other ones. Anyway, I'll move on. The H1 drugs that are commonly, the most common one is Benadryl. And a lot of these over-the-counter drugs have these antihistamines with all these other properties. And we use them in medicine for sleep aids. Oh, doxylamine is used for sleep. And that's marketed as Unison because it's anticholinergic, antihistaminic. Both cause you to be drowsy. You block histamine in the central nervous system, people get tired. All these are called first-generation antihistamines. Chlortrimetron, Tavist, Visceril, Meclizine, Atarax, cyproheptadine, Periactin. We use that one because it stimulates appetite by, yes, blocking histamine in the central nervous system and it's anticholinergic and it stimulates appetite. These all first-generation ones have been around for a long time. Don't get overwhelmed by all these names. But they crossed into the blood-brain barrier, having centrally acting effects of drowsiness, increased appetite, dry mouth, blurred vision, constipation, because they were dirty drugs. They hit antihistamine and anticholinergic because they were very small molecules. They were very fat. They got absorbed. They were very fat soluble. I mean, they crossed the brain because they were what's known as lipophilic. So then everyone's like, we've got to come up with something new. We need drugs that don't cross into the blood-brain barrier and that block that H1 receptor to stop anaphylaxis and stop the allergic reaction. Because these old drugs are too dirty. We use them for a million different things because they're dirty, because they do so many different things, because they hit that H1 receptor blocker, the histamine H1, and they hit the cholinergic, the alpha-adrenergic, the serotonergic. That's no good. So we need ones that don't cross the blood-brain barrier. They need to be bigger molecules, and they need to be fat dissolving, non-lipophilic. And they came up with them. Here it is. An antihistamine that doesn't make you drowsy, doesn't have all those effects. Claritin, loratadine. I love it. I use it. It blocks the histamine response in your body without going to the central nervous system. What's another one? Desloratadine, Clarinex, Allegra, fexofenadine. See, these are all common names. And all of a sudden, you're starting to realize, oh, that's what these are. Second generation antihistamines that don't make you drowsy, that don't go into the central nervous system. What's another one? Flonase. Aslastine. Flonase, centrally acting antihistamine. Ketotifen. It was initially used for your eye. What's that one called? Zadiator. But it's this peripherally acting antihistamine that doesn't come in your body. Cetirizine. And then levocetirizine, Oxal, and cetirizine. What's the brand name of that? Zyrtec. And there's another similar drug, Oxal. I think I'm saying that right. XYZAL. And Oxal, how do you say that? That's levocetirizine. These are all antihistamines. So now we talked about the H1. But there's more to the story. The histamine receptor has an H2 receptor. You're like, wait, I've heard about H2 receptors. So histamine is also in the stomach. Remember I said that? I said it's in the skin, the central nervous system, the stomach, and it's in the neurons, and it's in the heart. So what can you do with these stomach ones? These H2 receptors in parietal cells. What's going on with that? Well, I talked about mast cells. They store histamine, and when they're stimulated, they release it in the periphery. But there are enterochromaffin cells in the stomach which store histamine. And when it's released, the parietal cell, which is in the gastric mucosa, releases acid. Why this is all hooked into one system, I do not know. But these the histamine acts locally. So when it's released into your stomach, it acts locally in the stomach. When the lung one's released, the mast cells there in the periphery, they act locally. So that's kind of an explanation. But if you block those receptors, the histamine receptors and protocells, you can stop gastric acid secretion. And what can you treat? Which almost, I would say, a large 20-30% of America at some point is a gastroesophageal reflux disease. Gastritis, esophageal irritation from gastric acid. What are the drugs which block that H2 receptor in your gut? They're called histamine H2 blockers. Well, they were a major breakthrough. When they came, you know, when you had a stomach ulcer, they had to operate on you. Cimetidine was introduced when? I'm thinking the 70s maybe. But when that came, you could block gastric acid secretion in your stomach and it would heal. And you didn't have to have surgery. Cimetidine. Then came ranitidine. Then came famotidine. Then came nizatidine. Those 4 drugs are H2 blockers. Histamine 2, the H2 receptor blocker, which is a histamine blocker in your stomach. And they cured gastritis, esophagitis, gastroesophageal reflux disease. Man, that's huge. See why histamine is my favorite? Think about what you cause. Gastritis, gastroesophageal reflux disease. You save people from all sorts of rashes and anaphylaxis. Come on, this is huge. And I like it because it does that centrally acting H1 receptor. Think about what that does. When you stimulate that, remember which drug does that? Adrafinil, modafinil. That's an armodafinil. It's called, what are the brand names? Provigil and Nuvigil. Adrafinil is a nootropic. I did a talk on that, but it stimulates those centrally acting H1 receptors. You feel good, you feel energetic, you get projects done, improve learning, improve concentration, improve memory, weight loss, a sense of well-being, and may modulate addiction. Hello, see that? So now I talked about these H2 receptors, and then you'll say, well, these H2 blockers have an indirect effect on the proton pump in the stomach. There are other drugs which are out there which directly block the proton pump. I'll just mention they're not H2 blockers. They just block the protons, which is a hydrogen atom, which is hydrochloric acid, and it turns into hydrochloric acid in your stomach. Omeprazole, remember that one? It's over the counter, 40 milligrams at night. Prilosec, what's the other one? Esomeprazole, Protonix, Rabeprazole, Acifex, Dexlanis, Proprazole, Dexalon, what's the other one? Pantoprazole, Protonix. Oh yeah, Esomeprazole, that's Nexium. But those are proton pump inhibitors. Don't confuse those with the H2 blockers. So now, remember we still have 2 more. H3, remember that? The H3 receptor. What does that do? Well, there are H1 receptors in your central nervous system, but there are H3 receptors, which are the bulk of the receptors in the brain, in the central nervous system, in the hypothalamus. They're H3 receptors. And the hypothalamus is responsible for learning, concentration, sleep-wake cycle, initiating of activities, weight control, weight loss, addiction. I like that. That's my favorite histamine receptor, the H3 receptor in the hypothalamus. There are H1 receptors, I know, but it's the H3 is the Mac Daddy. Now, what's up with the H4 receptor? The H4 receptor, I said, that's involved with anaphylaxis, and the H4 receptor is in the basophils, right? And basophils are white blood cells, and there's tissue injury, or there's some sort of parasite or bacteria or some kind of insult to the skin or the body. Its release dilates the capillaries. You get leakage of white blood cells. So it's on the basophils, which is a white blood cell, and helps locally treat an attack that the body's experiencing. But the H3 receptor is also in the hippocampus and the cerebellum with projections into the cerebral cortex. So the H3 and H4 are in the central nervous system. This is the future. These drugs are the future. Think about it. Controlling addiction, keeping you awake, helping you learn, making you initiate activities. Come on, the H3 and the H4, this is the future. I talked about glutamate and in other lectures. That's a critical neurotransmitter, but when histamine is in the central nervous system, it's a neurotransmitter. And I think this is where the future of psychiatric drugs will be. These H3, H4 receptor stimulators and blockers, agonists and antagonists. Okay, so I ran through H1, H2, H3, H4. Thank you, Dr. Agresti, but there's more. Where does histamine come from? Well, it comes from an amino acid, histidine. You throw off our carboxyl group, which is CO2, and histidine, which is an amino acid you get from food, becomes histamine. Now, what foods are high in? Foods can actually have histamine in them and histidine. Foods high in histamine. You're not going to like this when I tell you. Alcohol, aged cheese, fermented foods, sauerkraut. What's that cabbage that the Koreans eat? Kimchi? That's fermented. Smoked or processed meats filled with histamine. Tomatoes, avocados, citrus, green tea, black tea, mate tea, loaded. Wine, loaded. Think about it. You have a histamine problem. You shouldn't eat these foods. Now, what foods are low in histamine? Fresh fish, fresh meat, eggs, fruits and vegetables, barring citrus, avocado, tomato. So that's the story there. Anything else I need to talk to about histamine? I think that covers it. That's a good review. And my philosophy here is get a roadmap of where you are and have a generalized understanding. And then from there, figure out weak points and research those. And hopefully I gave the watcher a general understanding of the histamine receptor, the H1, which is the histamine that's involved in anaphylaxis. And what we every day what we think of is a histamine response, runny nose and eyes and tearing and coughing. And oh, that's another thing. These antihistamine drugs may also have anti-cough effects. It's interesting. And that's why we see them in all these over-the-counter drugs. Pet peeve of mine, it's from another lecture, but Benadryl, remember I talked about that? It's an H1 blocker, diphenhydramine. Yeah, it also has anticholinergic effects. It blocks acetylcholine. That's what is low in Alzheimer's disease. And there is research that will indicate long-term use of Benadryl for sleep or doxylamine, which is Unisom, may predispose you or increase your risk to dementia. Don't be taking that. And then I get people come to my office, this makes me crazy. Oh yeah, I take a Tylenol PM. Don't do that. That's Benadryl, diphenhydramine, which long-term use can lead to dementia, and it's filled with acetaminophen, which is Tylenol, which is toxic to your liver. Tylenol is toxic to your liver. Don't be doing that. Okay, that's wrapped up. There's more on my blog, dragresti.com, and my book, Tales from the Couch. Thank you.